Lesson 4. Probability Formulae. There is a formula that you can use for two events to link the probability of their union and their intersection. If we have the probability of A is equal to A, the probability of B is equal to B, and the probability of the intersection is equal to I, then the probability of A or B will be equal to all three parts added together, which would be A minus I plus B minus I, which will be A plus B minus I. And as A is the probability of A, B is the probability of B, and I is the probability of the intersection, we get that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that is the first formula. Let's do an example. For two events A and B, the probability of A is equal to 0.6, the probability of B is 0.7, and the probability of A or B is equal to 0.9. Find the probability of A and B. We know the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So if you rearrange to find the probability of A and B, you get the probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. And so this will be 0.6 plus 0.7 minus 0.9, which will give us 0.4. There is another formula to find the probability of B given A already occurs. As A has already occurred, we restrict the sample space to only where A already occurs, and so this means the probability of B given A will be the part where B also happens, which will be I, over the total, which is A minus I plus I, or in other words, just I over A. And as the probability of B and A is equal to I, and the probability of A is just equal to A, that means that the probability of B given A is equal to the probability of B and A over the probability of A. Or if you'd like, you can rearrange this to get the probability of B and A is equal to the probability of B given A multiplied by the probability of A. Let's do one more example. For two events C and D, the probability of C is equal to 0.2, the probability of D is equal to 0.6, and the probability of C given D is equal to 0.3. Find the probability of C and D, the probability of D given C, and the probability of C or D. Part A, using the multiplication formula we just learnt, the probability of C and D is equal to the probability of C given D multiplied by the probability of D, which is equal to 0.3 multiplied by 0.6, which is 0.18. Part B, the probability of D given C is equal to the probability of D and C over the probability of C, which will be 0.18 over 0.2, which is 0.9. And for part C, the probability of C or D is equal to the probability of C plus the probability of D minus the probability of C and D, which is 0.2 plus 0.6 minus 0.18, which would give us 0.62. And that's about it.